We are talking about permutations and combinations today. For this video, we're just going to focus on permutations. So a permutation is an arrangement of objects in which order is important. That's the key point. With permutation, that means order is important when we're organizing or arranging objects. Now, in math, you'd be surprised, but we have a new symbol that we use that we're introducing today, and that's the exclamation mark. When you're talking and you say something with a lot of energy, it's usually, if you're writing it down, you put an exclamation mark. Well, we call this exclamation mark the factorial in math. A factorial is a positive integer, which is any number that's not a fraction, written with the exclamation mark. So we could say 4 factorial. And what 4 factorial just means is that we start with the number 4 and we start counting down and multiplying the numbers. So we'd go 4, 3, 2, 1, and we'd multiply all of those together, and that is our factorial. We use this to help us with figuring out how many possible outcomes could happen in a certain arrangement of objects. So suppose that you have 6 friends, but the photographer, you wanted only 4 people in the picture. There's 6 friends, but you only want 4 people in the picture. Using the fundamental counting principle that we learned from last class, the number of permutations of 4 friends taken from a group of 6 friends is 6, 5, 4, 3. So we start with 6, and we multiply it times 5 times 4 times 3, or 360. Okay? If you're still confused about what the fundamental counting principle is, you can watch a previous video. All right, so there is a way to make this much simpler, and we use this formula called the permutation formula. And another way of doing this, same example about the 6 friends and 4 friends in the picture, we could instead say 6p4. What's the probability? P stands for permutation. What is a permutation here? If you have 6 friends, but you only want 4 in the picture. So that's 6 total people, but you only want 4 at a time per picture. So what we would do is we would put 6 factorial at the top over 2 at the bottom. Well, how do we get those numbers? Well, here we have the formula. N is for the number of objects. P, permutation, taken 4 objects at a time, or R objects at a time, would give us the formula N factorial over N minus R factorial. Remember, N represents the number of objects, and R is how many objects at a time. So we could say there are 5 objects and we only want 2 at a time, or in the example that we talked about was 6 friends taken 4 at a time. In this case would be 5 factorial over 5 minus 2 factorial. So in the example above, we had 6 friends, we wanted 4 to be at the picture at a time. We would take 6 factorial over 6 minus 4 factorial, and 6 minus 4 gives us 2. So that's where that 2 factorial comes from. Okay? All right. And that's going to give us the total amount of objects or outcomes it would take for us to do that. So sometimes we also have some repeating objects. So let's say we have here in a game, it says you must try to create a word using randomly selected letter tiles. Suppose you select the tiles shown. So here in shown we have 2 O's, 1 S, 1 L, and 1 P. If you consider the letters O and O to be distinct, 2 separate letters, then there are 5 factorial or 120 permutations of these letters. 4 of these possible arrangements are listed below. 4 of these possible arrangements are listed below. So we could say pools, or pools where the first O is now the second O, or spool, exactly the same way where they switch the letters of the O's. Notice that unless the O's are colored, several of these arrangements would look the same. Since there are two O's that can be arranged in 2 factorial, or there are two ways each one can be arranged, the number of permutations of the letters O, P, O, L, and S can be written as 5 factorial over 2 factorial. How is this in a formula version? So the formula for this, when you have repetition of an object, you're going to put the number of objects at the top. So that would be n factorial. In this case, there are 5 letters, so 5 factorial. And at the bottom, r represents how many at a time, or which ones are which ones are repeating and how many times are they repeating. So in this example, we have one letter that's repeating, and it's repeating twice, so that would be 2 factorial. So that's why it's 5 factorial over 2 factorial. But we may have other letters that could be repeating, and so we would add those, and so that's why you have r1 factorial, or the next letter that could be repeating, r2 factorial, etc., etc. All right. Okay, so it says a class is divided into teams, each made up of 15 students. Each team is directed to select team members to be officers. If Sam, Valencia, and Deshawn are on a team and the positions are decided at random, what is the probability that they are selected as president? That would be like first place, vice president, second place, and secretary. That would be like third place, right? So order here is important because we know that, president, vice president would be underneath the president, etc. So order is important. Because order is important, we know it's going to be a permutation. All right. So we know it's a permutation, so we can go ahead and use the formula. That's P, N, and R, right? And the formula is n factorial over n minus r factorial. So what is n? N is the total number of objects. In this case, there's 15 students. So not that students are objects, but in this case they are. Okay, so we're going to put 15. All right, so everywhere you see an n, we're going to put a 15. Now, how many at a time are we concerned with? Well, we want 3 places. We want to be president, vice president, and secretary. Those are 3 different specific places that you're concerned about. So 3 at a time. So R would be 3. We're concerned with 3 positions. All right, so then we are going to then calculate this. So 15 factorial would be the same thing as going 15 times, counting down, right? 15 times 14 times 13 times 12. Down here it would be the same thing, right? 15 minus 3 is 12. So this would basically be 12 factorial down here. And I'm just going to go ahead and stop instead of going all the way down and writing the whole thing. I can stop at 12 factorial, and remember the same number over another number is the same thing as 1. So those 12 factorials would reduce to 1. And so we would only have to multiply 15 times 14 times 13 in a calculator. And we would get the answer 2,730. So there's 2,730 different ways that this could happen. But the only one that they want to be president, vice president, and secretary in that specific order. What are the chances that it would be in that order specifically in this specific situation? What is the probability of this happening? So the number of favorable outcomes is the number of permutations of the 3 students in their specific positions. This is just 1. 1 out of 2,730 would be our favorable situation. So the probability would be 1 out of that 2,730. So here we say, okay, the favorable, or the one we want, is just 1. 1 out of 2,730. And so then our probability would be 1 out of 2,730. This would be the probability of that situation happening. That's out of a lot of situations. So they have a slim chance of this happening, but it's not entirely impossible. All right, so let's do an example with repetition. So here we have a game show. So on this game show, you're given the following letters and asked to unscramble them to name a U.S. river. If you select a permutation of these letters, so we know it's a permutation already, at random, what is the probability that they would spell the correct answer? So we want it to be Mississippi. So what's the probability, what is the chances of this happening, spelling it correctly? Well, how many letters are there? If you count up all the letters, we know that there are 11 letters. First of all, we know there's a repetition, right? We have an S here, another S here, another S, etc. We've got, what other letters repeating? I is repeating. Is that it? Letter P is repeating as well. Okay, so we have repetition here. Okay, so we have repetition. Okay, because we have repetition, we're going to be using the formula n factorial over r factorial times r factorial times r n factorial, right? So this is the formula that we'd be using. N represents the number of total objects. In this case, we count up how many letters we have. We have 11 letters. And so we're going to replace our n with 11. And then r represents how many at a time are we concerned with? Which ones are repeating and how many times are they repeating? Well, we can look at our i's. How many times is the letter I repeating? Well, 4 times. So we can start with that. We know that the letter I is repeating and it's repeating 4 times. So we're going to go 4 factorial for 1. Let's look at another letter. The S's are also repeating. Well, how many times are they repeating? Well, if you say they're repeating 4 times, that is correct. So we're going to put 4 factorial. There's another letter that's repeating, and that would be your letter P. And letter P is repeated only twice. So we are going to not put 4 factorial, but we're going to put 2 factorial. And then we're done because that's the only ones that are repeating. All right, so here we're going to you can put this straight into a calculator just like that, or we can simplify it here. We're going to get a humongous number at the top. So we're going to get 39,900,000 or something like that, 916,800 over 1152. You divide these and you get 34,650. Whew! There is only one favorable arrangement. This is the amount of different arrangements you could get, but we only want one out of those. So what is the probability that you are going to be able to spell correctly the letters Mississippi in order? Okay, so only one favorable outcome. Favorable means that's the one we want. Only one favorable outcome out of that number. So once again, remember, probability is always written in a fraction form. So that's 1 out of 34,650. That's a very small chance of you being able to do that. Okay? All right, and that's your permutations.